All right, guys, here we go. Lab 7, classification of chemical reactions and rockets. So we're going to skip over to the procedure where we're going to go over some reactions. So we've got several reactions. We've got 14 reactions to be exact that I am going to do for you. And you're going to make observations on, and then you're going to classify those reactions. All right, so reaction number 1. Add a small piece of zinc metal, about half the size of a pea, or 5 millimeters of zinc ribbon to 2 milliliters of 6 molar hydrochloric acid. All right, so this is going to be our reaction 2 for reaction number 1. I'm going to mark it with reaction number 1. I'm going to get my approximately 2 milliliters of 6 molar HCl, hydrochloric acid. All right, 6 molar HCl. Bring this over here so I can put it down. Hopefully you can see it okay. I'll move it so you can see it better here in a second. I've got small, nice, shiny bit, about that 5 millimeter piece of zinc ribbon. There's my HCl. And we're gonna take a look at that. What is it doing? So you can see the zinc metal reacting, right? We got gas bubbles being given off. I don't feel any temperature changes. It feels like the same temperature. We've got all kinds of bubbles being formed. It's not easy to see, is it? I'm gonna give a little background. I don't notice any odors, but there's a lot of bubbles. All right, that is reaction number 1. We'll come back and look at that again. We'll look at them all. After we've gone through them all, we'll let it sit and do its thing. All right, reaction number 2. We're gonna add a small pea-sized amount of solid sodium carbonate, Na2CO3, and then to the bottom of a test tube, and about 15 drops of 6 molar HCl to it. All right, so reaction number 2. Label my test tube so I don't get confused. My solid sodium carbonate. I'm gonna go ahead here. Let's get a nice big scoop so you can see it. It's like a fine white powder. Actually not super fine, you can definitely see those individual granules. All right, so I'm gonna get a pea-sized amount. I think that looks about like a pea-sized amount. Oop, put that in, close it up. There's that. You guys hear that? Hear the other reaction still bubbling? That's what that is. All right, so 15 drops of my 6 molar HCl. Want to hold that up behind this? Perfect. So 1, 2, 3, 4. All right. So, I don't know if you guys can see all that. There's definitely like a light gas coming off the top of the test tube. All kinds of bubbles being formed. The test tube is definitely getting warmer. So it's bubbling away. Feel that?
Wow, I can really this game for.
Mm-hmm. So the reaction is creating
Oh my
heat.
gosh, the other one's completely gone.
All right, that is reaction number 2.
The other one's gone completely.
My assistant is noting that reaction number 1 has completely dissolved the zinc metal, so that small zinc ribbon from reaction number 1 has been completely dissolved. All right, we'll come back and make more observations on 2. 2 definitely let off all kinds of bubbles. It was warm to the touch in the test tube. All right.
What's next?
Reaction number 3 is up next. So reaction number 3, we're going to add about 3 milliliters of 0.1 molar calcium chloride to about 2 milliliters of 0.1 molar sodium phosphate. All right, so reaction number 3. All right. Some clean dippers for in there. So I don't get it mixed up. Okay. So we're going to put the 0.1 molar sodium phosphate in first, about 2 milliliters of it. Let's see, it itself is a clear, colorless solution. There's 1-ish. There's 2. Dropper with it in case I need it again. All right, so now I'm going to add about 3 milliliters of 0.1 molar calcium chloride. Again, clear, colorless solution. Would you hold my background up, please? Okay. One. 2.
What's going on?
And 3.
Turning into a salad?
Yes. All right. So you can see we've got the formation of a salad. Let's see how clear I can get that for you. Boop. Come on, focus in on it. All right. So if you can see in there, it's hard. It just looks cloudy to you.
Not warm?
It's slightly cooler than it was, though.
Oh my gosh, it is. What is
Okay.
it forming?
So you can see we've got a precipitate being formed. We've got a white, fluffy solid that was formed in this reaction. The chemistry word for fluffy is flocculent. I think I said that before. All right. All right, so that is reaction number 3. Reaction number 4 requires us to place approximately 0.5 gram of anhydrous copper sulfate. Anhydrous meaning that those water's hydration, like in our previous lab, have been removed and they don't exist part of this crystalline structure. In the bottom of a test tube, and we're going to add about 10 drops of water to it slowly. So this is reaction number 4. Half a gram. So our anhydrous copper sulfate, slightly blue in color.
Stuff's not going to spill.
So it's a light, fluffy powder. Okay, let's go ahead and add some water to it and see what happens. Can you guys see what's happening there? It's turning blue. Getting much darker blue as the powder kind of dissolves into the water. I'm gonna add a little bit more water. Tap it, mix it up. So we went from a pretty much white powder to this pretty tealy blue solution. Okay. All right, that was reaction number 4. All right, reaction number 5. Reaction number 5, we're going to place approximately 0.5 gram of copper 2 hydroxide in the bottom of a test tube and heat it with a Bunsen burner. So copper 2 hydroxide, reaction number 5. Reaction number 5. Place that there. Our copper 2 hydroxide. About 0.5 gram of that. Okay. Pull my Bunsen burner over. Without knocking anything over. Touch that. I see.
What kind of gas is this?
All right.
Turn on
the gas. Yep. Open it. So it's parallel. Yeah. There you go.
Woohoo. Do you want me to turn it down?
Oh, I'll turn it down at the Bunsen burner. Thank you. All right. Watch that for a second. All right. Got my Bunsen burner going. I've got my copper 2 hydroxide. Got black or a green powder. I'm going to go ahead and heat it up. I can see it changing color. Hopefully you guys can too. It looks like you can. Keep your head back. See it turning black. See some steam condensing on the outside or the inside of the tube. So we've got a color change going down. Changed colors. Will you turn my gas off, please, lab assistant? Thank you. All right, so we got a color change. We went from that greenish gray powder to a black powder. We saw some water condense on the inside of the tube. And I held it with test tube tongs so I didn't burn my fingers. All right, so that was number 5. Let's let that cool down and we'll check it out again at the end. All right, that's hot, don't touch it.
I'll go there.
Reaction number 6. We're going to take a small amount, the tip of a micro spatula, okay, of manganese dioxide catalyst to a test tube containing 3 milliliters of 3 molar hydrogen, or 3% hydrogen peroxide. and the catalyst does not appear in the overall reaction. It just makes the reaction happen faster. So reaction number 6. Reaction number 6. Go ahead and put about 3 milliliters of my hydrogen peroxide in. Second, it's not open. There we go. Right. Just off the shelf, 3 molar, or 3%, I keep saying molar, it's percent, 3% H2O2. And my manganese dioxide. All right. It's just a teeny, teeny bit. Your background, please. All right, here we go. Here's my manganese dioxide. It's a fine black powder going into my clear colorless hydrogen peroxide. If you see any like condensation, it's because the H2O2 just came out of the fridge, so it's pretty chilly. Okay, dropping it in. All right.
Is there any heat?
Yeah, it's definitely warming up the test tube. It's still a little chilly at the bottom. The test tube itself is warming up from the reaction. All kinds of bubbles. You can't see. All kinds of bubbles are being formed. See, a little bit of condensation on the inside of the test tube. Keep your head out. Okay. All right, that was reaction number 6. All right. Reaction number 7. It's gonna be sad that you don't get to do this one. This one's kind of like a stinky one. All right, so put 3 grams of solid ammonium chloride and 7 grams of strontium hydroxide octahydrate into a 125 milliliter Erlenmeyer flask and swirl for several minutes. In addition to the usual observations, check the reaction for both sounds and odors. Gently waft some of the vapor toward your nose. Be lucky that you don't actually have to smell this one.
Can I smell it?
Yes, you might want to actually back up, little lab assistant.
Why?
All right, because it's really stinky.
What does it smell like? Oh.
All right, reaction number 7. 3 grams of sodium, solid ammonium chloride, and our strontium hydroxide. All right, my ammonium chloride, NH4Cl. Kind of a white crystalline powder. Chase. Okay. And strontium hydroxide octahydrate. All right. Again. Check out that solid in there. Let's see. I'm gonna go weigh these, and I'll be right back to do this reaction for you. All right, here we go. Back with our ammonium chloride in our Erlenmeyer flask and my strontium hydroxide in a beaker. All right, so now I'm gonna go ahead and combine the two. Got my vent hood on, but it's not gonna smell great. Come on, get in there. Perhaps I should have gotten a funnel. Now I didn't get specific masses. The specific mass isn't needed. We're just doing qualitative observations, not quantitative measurements. It'll be more quantitative in a few labs.
Is there anything else you need?
All right, there we go. It's a good thing it's not quantitative because I made a mess. All right, here we are. We're gonna mix them together, swirl it,
Should I back up?
swirling the two solids together for several minutes, as instructed by the lab handout. Oh, there it goes.
Can I touch my eye? I used water.
All right, so you can see the solid's kind of starting to change form. It's a little bit more clumpy, like clumped together in big clumps instead of the two separate solids in there. It's getting very cold to the touch. It's very cool to the touch, and there's a strong ammonia odor.
That's the only thing.
That was a very good waft. So the proper technique for smelling in a chemistry lab is not to directly sniff something, because you could very much, especially in this case, regret it, is to waft the smell. So, there we go. You can kind of see condensation and stuff building up around the bottom of the Erlenmeyer, and it is getting like really quite chilly
Why is it so cold?
to the touch.
Oh, wet. That's like AC right there.
All right, so I'm trying to swirl, but everything's all stuck together at the bottom of my flask. That's not really moving anymore. It's kind of just gooped there, and it is quite smelly, a very strong ammonia odor. All right, we'll look back at that guy in a little bit. I'll set it over there, away from my face. Okay. That was reaction number 7. All right, reaction number 8. We're going to add 2 milliliters of 3 molar sulfuric acid to 4 milliliters of 3 molar sodium hydroxide. All right, sulfuric acid and sodium hydroxide. Thank you. Reaction number 8. Okay. A couple of these guys. All right. 8, 2. So 2, so the 3 molar sodium hydroxide. I want about 4 milliliters of that. So 1, it's a clear colorless solution, is at room temperature. 2, 3, this barrel pipette fills up to about 1 milliliter, by the way. 4, all right. All right, so now I'm going to get about 2 milliliters of my 3 molar sulfuric acid. I'm going to go ahead and add that in. There we go. Adding the sulfuric. 1 and 2. All right. So the two have mixed together. It's still a clear, colorless solution. but it is quite warm to the touch. So we're giving off a lot of heat in this mixing in reaction number 8. There aren't any odors, but it's given a lot of heat off. All right, that's reaction number 8. All right, reaction number 9. So we're gonna add 2 milliliters of 0.1 molar calcium chloride to 2 milliliters of 0.1 molar sodium carbonate. Let's see, my calcium chloride is down here somewhere. Thank you. Reaction number 9. Always labeling so you can keep track of things. So we're going to put our sodium carbonate in first. Approximately 2 milliliters of my sodium carbonate. 1 and 2. All right, and now my 0.1 molar calcium chloride, another clear colorless solution that we've used earlier. I'm using again. All right, action number 9. Adding it in. Forming a milky white precipitate. Let's see, I've got about 1 more milliliter to put in. Let's work that in. There you go. All right, so we formed a milky white precipitate. It's kind of hard to see. There's a little bit of fluffiness in there. It's more like thin milk, I suppose. Let's see. Can't tell you if it smells or not. All I can smell is ammonia. All right, so that is reaction number 9. All right. Reaction, let's put this back over here. Reaction number 10, we're going to place approximately 2 grams of copper 2 sulfate pentahydrate in the bottom of a test tube, and we're going to heat it with the Bunsen burner. All right, so reaction number 10. So we did something similar to this, right? In our last lab, we heated a hydrated salt to drive off water. Let's see, how much was it? 2 grams? Approximately 2 grams. Scoop up some. Just enough so you can see what's happening. All right, so my copper 2 sulfate pentahydrate is a very pretty royal blue. Reaction number 10. Got all kinds of crystals in there. All right, let's light my Bunsen burner. Gas, please. Thank you. All right. Let's go ahead and heat it up. All right, got condensation right away on the inside of the test tube. And my solid is turning white. Lots of condensation, some steam coming out of the top of the test tube. It's actually starting to boil on the inside of the test tube. You guys can hear that. All kinds of it coming out. I feel like the camera's not really picking it up. You can see it turning white. And kind of sizzling. just like our last lab, or not last lab, our lab number 5, where we did the determination of an empirical formula. It's going from blue to white. I'm going to stop heating it because I'm overheating it. It's starting to turn brown and burn and decompose. My copper sulfate. Gas off, please. All right. So it's a little bit blue on the inside, only because I couldn't shake it around. Lots of water, condensation around the inside of the test tube, steam coming out of the test tube, and we went from that blue color to a white color. And that was reaction number 10. All right, reaction number 11. Add 2 milliliters of 6 molar hydrochloric acid to 4 milliliters, of 3 molar sodium hydroxide. Reaction number 11. 3 molar sodium hydroxide. That is right here. All right. So from the previous run, we have 3 molar sodium hydroxide. We're going to put approximately 4 milliliters in. So 1, 2, 3, and 4. Again, nice, clear, colorless solution. Put the lid back on. I don't want to spill anything. And how much? 2 milliliters of our 6 molar hydrochloric acid. So I have that out in a beaker. So I have a big container. So here we go. 1 and 2. All right, so you can see swirls where the two mix together, where acid and base mix together, and we get, what do you feel, Chase?
Cold at the bottom, warm at the top.
Where it's mixed together, the test tube has gotten very warm. We've given off quite a bit of heat.
At the bottom, it's cold though.
Comparatively to the top.
Like my finger feels cold.
Okay. So, still a clear, colorless solution, but the test tube is quite warm. All right, that was reaction number 11. 3 more to go. All right, reaction number 12. Add 3 centimeters of clean copper wire to 3 milliliters of 0.1 molar zinc in a small test tube. I said that wrong. Zinc sulfate, sorry. This is reaction number 12. All right. Copper wire, zinc sulfate. So let's go ahead and put our zinc sulfate in, about 3 milliliters. Clear, colorless solution. One, 2, and 3. So that's our 3 milliliters of zinc sulfate. 0.1 molar zinc sulfate. And our little copper wire. Okay. Let's find a shinier piece. Alright. Put that one. That should go. Alright. So a thin, approximately 3 centimeter. Oh, can't even see it. Let's see. 3 centimeter piece of copper wire going into our zinc sulfate for reaction number 12. Well, that is less than exciting. I don't have any bubbles. I don't have any temperature change. I just have a piece of copper wire sitting in a test tube for reaction number 12. All right, for reaction 13, we're gonna add a small piece of zinc metal to 3 milliliters of copper sulfate. So our 0.1 molar copper sulfate is a pretty blue solution. Copper tends to make very pretty solutions. And we've got our zinc metal from before. We can get about 3 milliliters of copper sulfate. Alright, so our copper sulfate. Color is almost kind of like Windex to me. Alright. I've got the same little zinc metal from earlier that we dissolved in reaction, I think, number 1. So tiny piece of zinc metal, my copper sulfate, and still getting wafts of ammonia over here. All right, let's see. So this one's a little bit harder to see for you guys. Let's see if I can zoom in on it and kind of show you what's going on. So the zinc is changing color. It's getting darker in color. It's turned almost black through the solution. See if I can focus on it. All right. Oh, I didn't label my test tube. That was reaction 13. We're gonna give that one a little bit, and we're definitely gonna come back and make some more observations on reaction 13. Okay, put that there. All right, so our last one, we're gonna add 2 milliliters of 0.1 calcium chloride to 2 milliliters of sodium nitrate. Reaction 14. All right, sodium nitrate, 0.1 molar, NaNO3, and we need our calcium chloride again, right? Let's get, I'm just gonna measure it this way. How about 2 milliliters of the sodium nitrate, which is a clear, colorless solution. Clear colorless solution. Let's go ahead and add about 2 milliliters of calcium chloride. Addition number 1, milliliter 1, milliliter 2. Okay. Let's go ahead and look at that. Not a whole lot going on. We've got a clear colorless solution, no temperature change. Pretty sure no odors, but all I can smell is ammonia still. All right, that was our last reaction. So make sure you're looking at your solubility rules for what should be happening in these reactions. Let's get this out of the way and let's take a look. Do a brief review of all 14 of our reactions and take a peek at everything we got going on. One last double check as they sat there. All right, test tube number 1 for reaction number 1. So reaction number 1, if you flip back in your notes, reaction number 1 is now just a clear colorless solution, and the zinc is completely gone. All right, reaction number 2, we've got a little bit of white solid at the bottom of the test tube, and a clear colorless solution on top of it. So that precipitate settled out of solution. Reaction number 3. We still have our solution, our precipitate. Got it stuck there in the bottom. All right, number 4. We've got a little bit of solid still at the bottom. Let's try something. So we've got that blue solution and a blue solid at the bottom. Let's add, that was watering. Anhydrous, right? All right, so let's add a little bit more water. See if we can get the rest of that to dissolve, just for fun. Yep, a little bit more water. All of that dissolved into solution. And pretty blue solution, which is very typical of our copper solutions. Number 5, we heated up some copper hydroxide. So we have a black powder in the bottom. Reaction number 6. What was it? We added that manganese dioxide to some H2O2. We saw lots of bubbles and gas coming off. Number 6. Oh, here comes number 7. Number 7, the Erlenmeyer flask is still quite cool. Ooh, look at that. You guys see that? Given enough time, it's kind of like a liquid on the bottom. Still super stinky. But we formed a liquid on the bottom. I'm going to stop moving it because it makes it stink more. It's quite cold still. All right, number 8. Number 8. Actually, it's still warm. Clear and colorless. Number 9. We've got our precipitate kind of settled out now, and we've got a little bit clear colorless solution on the top. Number 10. We've got our dehydrated copper sulfate. Number 11. Got some bubbles. Number 11's a little bit warm still. A bit of bubbles there. A little bit warm still. Number 12. Number 12. We still have our copper wire. Just kind of chilling. If anything, it looks a little shinier, like it's a little cleaner. 13. Let's see, what do we got going on in here? Definitely had a color change. It's really hard for you guys to see. I really wish you could see it better. But we've got a color change in that zinc in the bottom. It's a dark black from the shiny metal that it was. Let's get a shiny metal that it was and show you. So you can compare and contrast. See that change? There you go. All right. That was 13 and 14. One of our least exciting reactions. All right. That is all 14 of our chemical reactions. All right, here we are for part B of experiment number 7, where we're going to do the pipette rockets. Now, you don't have to write up the entirety about the shooting of the rockets, but just write up about the gas generators, okay? But we're gonna do a little of the rocket shooting just for fun. Okie doke, here we go. So what we have in front of us is the beginning of the setup for part B, our pipette rockets. So we're gonna use 2 of our reactions from part A that generated gas, and we're gonna generate hydrogen and oxygen gas, which are going to be flammable or explosive sorts, and propel our pipette rockets. So I've trimmed a barrel pipette, which is this guy here. I cut it about here, and I cut it about here, and I've done the steps of inserting it. So there's what we're gonna launch in the pipette or in the rocket portion, and I went and stuffed this half down here through our stopper, and I've done that twice to create both of our gas generators. So I've gone through the steps, which you can read through, and gotten everything all put together. Cut the tip, inserted it, got the rocket part. I did it twice, one for each generator. And then I went and measured out very roughly about, so we're not gonna worry about exactly how much, but approximately 4 grams of our 20 mesh granular zinc. So the 20 mesh just is the size of the grains of our zinc. So here's our zinc granules, or our mesh. So guys, there's my perhaps heavily handed portion of zinc that I'm going to use. So I'm going to go ahead and I'm on step 2. I'm going to put that zinc into one of our gas generator systems. Drop that water. I don't like messing with worktop. Anyway, so here we go. My gas generator system number 1 for step 2. Make sure you can still see what I'm doing. Got my portion that I weighed out on a little bit of weigh paper. Go ahead and pour it into my test tube. All right, there we go. Weigh paper out of the way, put that back. Put in about 15 milliliters of 6 molar hydrochloric acid. I just have it in this big beaker for support to hold it up for me, so I'm not making a mess. There's my 10, my 15 mark at the bottom. So this is 6 molar hydrochloric acid. Portion out my volume, and I'm going to go ahead and put that in to the gas generating system and replace my pipette tipped stopper. Oh boy. Okay. It sure is bubbling away. Let's see. Lots of bubbles. Very warm. Oh, no, you can't. My hand's in the way. Lots of bubbles. Very warm. Generating all sorts of gas. Going crazy. Super fun. Okay, so go ahead and put that back on. You can see the gas coming up. You see it? But there is gas coming out of my little pipette tip. All right, so there we go, generating gas. Wait 10 seconds before starting gas collection. So I think I've talked through at least 10 seconds. So we're gonna fill the first collection bulb with water by submerging it in another beaker of water. Got that right here. I'm gonna squeeze it to all the, let's see, I need to get that into the picture too. So many things happening all at once. All right, so fill it up. If I do it that way. Move all the air out of it. So I'm just squeezing it underwater so it's completely filled with air. It's gonna make a mess on the countertop. Drives me bananas, but it's okay. There we go. Filling, replacing the water with the gas very quickly. I'm gonna light my candle, and we're gonna see what it does to the candle flame. Just kidding, not that much. Okay. All right, candle's lit. Gas and squeeze. Okay. Let's do it again. bubbles out. Put it over my gas generator. Fill up my collection bulb. Replacing the water with the gas we've generated. So you can hear it making a little popping noise. One more time. Make a second generator if we need to. Okay. Okay, so while that's going, I'm gonna take and I'm gonna move on to step 4 where I'm gonna create the second gas generator. I'm gonna second one of these if we need to. All right, build that up. Anywho, there we go. I'm just gonna put that there for fun. All right, so step 4. Let's create a gas generator by placing about 4 grams of our manganese, which I have weighed out right here. Let's see if you can still see what I'm doing. Move this generator over a little bit out of our way. Clean up our mess. Move this one. So figure 2, we're gonna have a little bit of warm or room temperature water rather. And I'm gonna put my manganese in my test tube. Using my white paper to kind of transfer it, get it in there. Approximately, very approximately 4 grams. And I'll be quantitative, we're gonna be quantitative. My 3% hydrogen peroxide measured out. There we go, it's about 15 milliliters. Give it a second. There we go. You can see it's starting to go. So yeah, oxide layer on the outside of the manganese because it's all rusty and brown. I forgot to show you that. You can see the gas bubbles starting to form. There we go. So it's getting going. Let's see, you can see it at the top. See it bubbling up. Reaction's happening, creating gas, oxygen gas. All right, that generator is going, producing its gas, putting it in the water bath next to the hydrogen generator. You can add more peroxide if we need it. So we're gonna do the same thing that we just did. I'm gonna put my tip back on. See it bubbling away. We're going to do the same thing. Some collector bulb for this gas. Squeeze out all the air. Replace it with oxygen. Definitely a little bit. Ooh, you can't see that at all. It's so blurry. There we go. Alright. See that? It's definitely going a lot slower. See those bubbles coming up. Replacing the water with the O2 gas. Slowly, but surely. Hydrogen generator is bubbling away like crazy. There we go. We're almost there. So close. Just a little bit, still dribbling out. So close though, so close. Just another second. All right, I think it's gonna be good. We're gonna call that good. Ready? Squeeze. That was less than impressive.